Good morning. Firstly, I want to acknowledge the Ngambri people that own this land and acknowledge their elders, past, present and emerging. And secondly, I want to acknowledge the Gundungurra people who own the land where I come from, which is Crookwell, about an hour north of here. I'm Charlie Prell. I'm the Chair of Farmers for Climate Action. Welcome to the second day of this amazing conference. I want to also acknowledge Jenny and the incredible input that you've had in organising this conference. It's a wonderful experience. And also the dinner last night was fantastic. So thank you, Jenny. I'm Chair of Farmers for Climate Action. That's an honour and a privilege. And we're now the fourth most influential environmental group in Australia after just 5 years. I really encourage you to reach out to our website, our YouTube channel, our Twitter if you do Twitter, or our Facebook feed. Our mission is to change the politics in relation to climate. And personally, I think we've been very successful with that, but I'll leave you to judge that. I'm very proud to be here, and I'm very honoured to have the pleasure of introducing the speakers to you this morning. One of the speakers, Dr. Ian Dunlop, will be via Zoom, so you'll be watching the screen. We have some extraordinary wealth of knowledge in this room and breadth of knowledge. And I'm looking forward to exploring the knowledge that you're going to hear today. The first speaker this morning, firstly, let me say this forum is organised and run by Sustainable Population Australia, and Sustainable Population Australia have just produced this document, which is on their website. It's called Population and Climate Change, and addresses the challenge of population growth. There was a couple of questions yesterday about the seeming unending growth of population in Australia. So I commend that publication to you. Not now, because now it's going to be really interesting, but maybe in this evening. So it's my absolute honour to introduce you to Dr. Mark Howden, the first presenter this morning. It doesn't say it here, but Dr. Mark Howden is a Deputy Chair of the IPCC, and he's been instrumental in making sure that everything that we do, Farmers for Climate Action, is based on science. And he's been telling people for 50 years or so now that what's happening now is coming. And he has the incredible ability to connect with people, an incredible ability to make complicated issues very, very understandable and simple. And it's a real honour to introduce you to Mark Howden. So Mark, welcome to the stage.
Thanks very much, Charlie, and thanks to Jenny and the other organisers for the opportunity to be here today. And so what I'm going to do is just give a very quick update on some of the climate science, drawing from the two recent IPCC reports. That's the Working Group 1 report on climate science and Working Group 2, which was released a couple of weeks ago, which is on impacts and adaptation, plus with additional information. And the intention here is just simply to provide a broadly understood sort of set of information which relays our best understanding of how climate change is going to impact on sustainable agriculture here in Australia. And the sort of picture is intended to be evocative about, what is the future that we're actually heading into. So one of the things I just want to raise here is in relation to this quote, which came from Daniel Kahneman, who's a really well-known psychologist, going back a few years. And And this quote was actually brought to my attention by Rebecca Colvin, who's one of my colleagues here at ANU. And basically the proposition was that the human mind is simply not equipped to deal with climate change. It's a type of problem which doesn't easily fit into our cognitive processes. And the fundamental argument here was that climate change is too distant, both in terms of geography and in terms of time. It's too abstract and it's too contested to actually be easily understood by people and taken action. And what I actually think that these recent IPCC reports, building on huge amounts of science and data collected across the globe, essentially explodes this proposition. Because I would argue now that climate change is not distant. It is here right now, as we can see, is happening up in the East Coast, or the heat event in Townsville, which is related to that, or the hot weather, they've experienced record hot weather in Perth and in Darwin, or the summer fires, or the droughts, etc., all have climate change embedded in them. So it's not distant, either in terms of time, it's here right now, and it's not distant in terms of space. It's actually happening to all of us, and it's happening right across the globe. And so whether in your Western Australia, Northern Australia, Tasmania, etc., it is there in front of you. Secondly, is it abstract? Well, no, this is actually really very real, as I'll show you a few examples of, which is impacting on really important things right now, including agriculture. And is it contested? Absolutely not. The Working Group 1 report, one of the headline statements from that is climate change, human influence on climate change is now a fact. It is not equivocal. It is established beyond doubt that humans are influencing the global climate. The most recent report, Working Group 2 report, said essentially the same thing. Humans are impacting on things we value through climate change. So whether it's biodiversity or agriculture or water systems, we are having impacts. The contested part is removed, and people who pretend it's still contested are actually trying to pull the wool over your eyes. So what's driving this, of course, is fundamentally greenhouse gas emissions. This is one of those greenhouse gas emissions, carbon dioxide, in this case from fossil fuel and industrial processes. This is a graph coming from the IEA. Sorry about the faint line, but that's just how it came off the system, and I couldn't download the data to actually make a better graph. But you can see this goes back to 1900 up to the present, essentially an exponential rise in terms of carbon dioxide emissions. And you can see there's been a couple of little blips. There's the global financial crisis and COVID, both of which drove down temporarily greenhouse gas emissions. And in both cases, there's been a bounce back. The bounce back from COVID is actually now resulting in this last year's emissions exceeding those of the pre-COVID conditions. And I expect this year's emissions to again exceed those of last year. So we're not doing what the Paris Agreement says we should be doing, which is starting on this long sort of decline down here, or hopefully a steep decline. We should actually be sort of hitting the 0 point around there on that wall is what we should be doing. And we're not doing that. So all of the stuff in the Paris Agreement, 30% reductions and 45% reductions, it's not showing up in terms of the global emissions record. So we're not doing what we said we'd do to put a cap on climate change. Interestingly, if you look back at the start of this record, whoops, again, I'm getting the buttons wrong. If you look at the start of this record, emissions back in 1900, about 2 billion tonnes. If you actually look at the end of this record, emissions went up by more than 2 billion tonnes in last year. So the increase post-COVID was bigger than our total emissions globally 120 years ago. If you want a startling statistic, that's one you should think about. The variation from year to year or growth from year to year is of that scale. Now we know, and incredibly well documented through those IPCC reports, that these carbon dioxide is translating to higher temperatures. Recent years have exceeded 1.2 degrees above pre-industrial, and 1.2 is a huge change in terms of the Earth system. So that's roughly speaking a quarter of an ice age's worth of temperature change, but obviously in the other direction. So an ice age cools the Earth down by about 5 degrees. We've already pushed it up by about 1.24 degrees. So, we've already generated a quarter of an ice age's worth of change, and ice ages fundamentally changed the face of the world. So when we look at the evidence base for impacts, it's very clear that climate changes that we've instigated are now hitting every continent, every island system, every ocean, every system that we rely on as humans. And this is just a summary graph, which we won't go into the detail of, but it basically on the downward side, it lists different regions of the world and a global number at the top. On the top level, it's impacts on things like water and food, impacts on health and well-being, impacts on cities, settlements, and infrastructure. And against each of those, each of the little round things has a plus. In other words, it's entirely positive. A minus, impacts are essentially negative, or ambivalent, because there's both. There's a plus and a minus. And if you actually look at, say, Australia, with one exception, there's only one little plus sitting in there. And if you look at the graph right across the the world and those different ecosystems, there is no single cell where there is only a plus. And almost every cell has is occupied just by a minus. So the conclusion from this is the overwhelming impacts of climate change to date have been negative. So we can't argue that, climate change has pluses and minuses about the balance between the benefits and the disbenefits. It's overwhelmingly negative. And I think that's a key message we need to send. Now, does this impact on Australian agriculture? And this study has already been referred to yesterday, but this was a study done by ABARES. They ditched the usual approach of using simulation models, and instead they used hard data of farm production and profitability. And what that showed is that climate change is already impacting significantly on farm profitability in Australia. So on average, across the broadacre industries, about 22% reductions in productivity and profitability. And of course, this is not evenly spread. So some parts, the red parts, are where that's impacting particularly negatively. And you've also got a couple of parts up in the north which are blue and which indicate a positive impact. And that's largely through increases in rainfall. But if you said, okay, well, maybe that's just a peculiarly Australian thing, well, it's not. So when you look at a global study which used exactly the same sort of methods to separate out the climate change signal from the technology and management signal, this is what you get. And so, but this global study showed is that on average across the globe, the reductions in agricultural productivity compared with what would have happened in the absence of climate change are roughly the same as what's already happened in Australia. So we're just sitting on the global average. But sitting on the global average means that there's big parts of the world, the red sort of colours on this graph, which are actually much worse affected by climate change than we are. And you can see Central America, the north part of Africa, and through Southeast Asia, there's places which have between 30 and 40% reduction in agricultural productivity compared with what would have happened in the absence of climate change. And if you look at those places, a lot of them are where there's a lot of very hungry people and people with really significant lack of nutrition in their diets. And you have to think about a counterfactual. So what would have happened if we hadn't had climate change? And one of those answers would be, we probably would have very few hungry people in the world, instead of about 1 in 10 people in the world going hungry from day to day. And that's what climate change is already doing. And that's, in my view, profound. Now, of course, in Australia, we need to think about fires, and the scars of our big fires are always with us. This is a study done by Pep Canadell and colleagues. On the right-hand side is the map of increased fire danger index. And you can see that particularly the southeast and southwest, but also parts of the north, are particularly badly affected to date by increase in fire danger. And regardless of whether it's the fire danger index or the intensity of the fires or the duration of fire season, we're seeing everything get worse. So every metric for fire is getting worse across Australia. And one of those metrics is the area burnt. And so if you look at the panel over there, you can see that's the panel on the right-hand side, or your left, is the area burnt during the standard fire season. So that's the spring-summer period. And you can see that that's basically going up fairly linearly if they just did a regression line, although Black Summer was a massive, massive outlier on that with, massive area burnt. If you actually then say, okay, well, what's happening between our standard, the start and end of the fire season, in the off season, and that's this graph here. And you can see essentially it's going up exponentially. So what we used to think of as the off-season in terms of fires and out of season is actually now becoming much more fire-prone, and we're seeing an exponential growth in the area burnt during that period. So there is no rest for the fireys. And importantly, it also means that that period, say when in Australia, we didn't have a lot of fire danger and we could take some of our firefighters across to places like California or across to Europe where they need them, that's no longer being constrained because this same thing is happening in California and Europe. They're getting fires in their off-season and they can't send their resources, the Elvis helicopter and their spare firefighters to us because they're having to deal with fires in that cool season. So implications of all sorts through here. Now, just sort of moving into the future side of things. So clearly what we see from the science is that our future is in our hands. This is a graph from the IPCC Working Group 1 report. We see different greenhouse gas emission scenarios starting from the 40 billion tonnes where we are roughly now. And high emission scenarios take us up to sort of 5-degree world. The low emission scenarios, which are consistent with the Paris Agreement, are these ones. The low scenario means you have to go to net zero by 2070-ish. The very low scenario, which is consistent, roughly speaking, with 1.5, you've got to go to net zero by 2050. But you'll notice in both of those cases, net zero is not the goal. That's not the end point. It's a waypoint on the trajectory. And in both cases, if we're to keep those temperatures down to 1.5 or 2, we have to take it below the line, below the zero line. We have to go negative emissions. And this is something that simply just hasn't really appeared in the public debate. Everyone's caught up politically and otherwise in the let's get to net zero as though net zero is it. We've done the job. Well, we haven't done the job. And so one of the things that can really significantly contribute to going below the line is better treatment of our agricultural lands, improving and raising carbon levels both above ground and below ground. And so there is a major contribution that land area here in Australia and elsewhere could, and I say could, play in terms of keeping those emissions down, those net emissions down. And so lots of opportunity potentially sitting here. And if we actually look at how well we're doing, as I said before, at the moment we're not doing really well. We're sort of maybe on this curve. We aspire to be on this curve, but that curve leads to a world of something like 3 degrees. So if all of the governments did what they say they did under the Paris and Glasgow agreements, we'd go onto that sort of curve, and we'd still end up with 2/3 of an ice age worth of change. And so at the moment, we're really not getting it if we actually look at the matching actions with words. What might a world look like under these sorts of temperature scenarios? So these are maps coming from the Working Group 1 IPCC report. I'll show the temperature first and then the rainfall one. But if we look, this is what the world would look like with a 4-degree scenario. Hopefully we won't go there. But the key messages here are different parts of the world heat up at different rates. So if you're in the Arctic or the Antarctic, you will heat up hotter. If you're on a continent versus the coastal edge, you heat up hotter. If you're on land versus the ocean, you heat up hotter. So there is no single temperature increase. It depends on where you are. So when we look at what that might mean in terms of change and impact, well, clearly there's going to be all sorts of direct and indirect impacts including in agriculture. So direct impacts through, say, heat stress on animals or heat stress on crops, and indirect impacts in lots of different ways, so changing the nutrient cycle, for example. We're likely to see significant increases in potential evaporation. We're already seeing that going up across the globe because of changes in the vapor pressure deficit. That will not only mean we lose more water from our surfaces, leaf surfaces, soil, dams and rivers, but also our water use efficiency reduces. So we get less productivity per litre of water. We're likely to see increased greenhouse gas emissions. So both in terms of carbon, if you get a hotter environment, you lose carbon. If you get a hotter and drier environment, you lose a lot more carbon. So climate change is going to be a threat to our ability to store more carbon on our landscapes, and not just through things like fires, but also through the fundamental processes which either bring carbon in or drive carbon out of those landscapes. And we heard some of that from Wolfram, for example, yesterday. And of course, there's a whole range of heat-related issues, including direct issues for humans, such as heat stress. Labour productivity goes down if you get higher heat stress. Health issues go up if you get higher heat stress. There's vector, food and waterborne diseases, which all linked to higher temperatures. And there's increasing evidence of mental health through both long-run chronic sort of climate issues and also acute climate issues such as cyclones or fire and similar damages. The picture is not looking good. If we look at rainfall, is that again, rainfall changes depending on where you are. Again, if you're in the Arctic or the Antarctic, you're likely to get a lot more rain. If you're around the equatorial Pacific, you're likely to get a lot more rain. But pretty much everywhere else, you're actually going to get less. And that includes the mid-latitude band where Australia sits, the subtropics and mid-latitudes. And you can see that sort of orange colours on that graph just there. But we're the same as South Africa and South America and parts of the US and Central America and the Mediterranean. We're not alone in this. And so what might happen with those rainfall changes here in Australia? So for starters, rainfall in the traditional rainfall season, April to October, the useful rainfall season in southern Australia is likely to decrease. And that's likely to decrease because the subtropical ridge, the big high pressure systems are growing stronger, they're growing bigger, and they're moving further south. And that's chasing the rain-bearing systems into the Southern Ocean instead of that raining over the land. So we're likely to see continuing reductions in autumn, winter, spring rainfall in southern Australia. The variability of rainfall in Australia, particularly Eastern Australia, is likely to go up. So El Niños and La Niñas already have more sting, and that's likely to increase in the future. So La Niñas get wetter, like we're seeing in recent weeks, and El Niños tend to get drier. And so that variability between the good seasons and bad seasons increases under climate change. And that has all sorts of implications, including for carbon sequestration and productivity, but also for investment. If you've got a riskier environment, your investment rationally goes down. And also, we're likely to see increased rainfall intensity with implications for flooding and erosion. So those sort of management of ground cover will become much more important, and that's an integral part of the discussions we've been having here. Just a couple more slides. So drought is likely to increase across the globe with a few exceptions, and that's because of higher temperatures, changes in rainfall, increased potential evaporation. In almost every analysis, that's going to drive up food prices. So if you can hang in there, there is some good news there. Food trade is likely to increase, and Australia being a significant contributor to food trade globally, again, may advantage Australia if we're well positioned. And the difference between being well positioned and not maintaining our comparative advantage is essentially how much notice we take of this and how prepared we are in terms of developing adaptation responses. And at the moment, we're not doing a great job of that. In fact, our adaptation effort across Australia has declined dramatically over the last decade. And so that proposition of who is going to adapt best is one which I don't think is a race we're winning at the moment. And the last slide I'll show is what we call the feasibility assessment of adaptations. So this is in the recent IPCC Working Group 2 report. What we did was looked at all sorts of different systems, so land and ocean systems, urban systems, energy systems, etc. Looked at particular risks in each of those different systems, and then identified some very aggregate classes of adaptation responses. And against each of those aggregate classes of adaptation responses, we assessed the feasibility of those. Now, I'll just zoom into the sort of water and agriculture part of that table, so it's more easy to read. But if we actually say, look here at sustainable agriculture and fisheries, we see the potential feasibility assessed based on the literature is moderate. It's not in the very high category. And that's based on all of these different categories: the economic, technological, institutional, social, environmental, and geophysical aspects covered there. And so each of these sort of different classes of adaptation is assessed, and they're also assessed in terms of their synergies with emission reduction. So, for example, if you look at the forest-based adaptation one, we see that adapting our forests is also likely to significantly reduce our greenhouse gas emissions. And so that combination of adaptation and mitigation is something we will have to increasingly take into the future. So it's not just responding to the climate change, but how can we contribute to solving that greenhouse gas emission problem that I showed on the first slide. And I'll just leave it there. And thanks, Charlie.
Thanks, Mark. We do have time for a couple of questions, and it's really hard to see here, but if there's anybody that has a question, could you come down to the microphones? This session's being recorded because the next presentation is on Zoom, so speak into the microphone, and if you could answer from here, Mark, from the microphone.
Thank you very much. That's a wonderful talk. I just wanted to ask, recent changes in ruminant emission methane treatment, looking at it as a short-term pollutant, the Miles Allen work from Oxford, has that changed how we look at ruminant emissions and the role that they might play? Does that mean that the 14% that we'd expect to build in fact, can be significantly reduced?
No.
Okay.
Do you want me to expand?
I'd actually a bit of explanation would be very useful.
We should be really clear about that.
Yep.
That's essentially an accounting approach which looks at how emissions currently relate to previous levels of emissions, and that's actually irrelevant to the climate, the atmosphere. So what really matters is how much additional methane we're pumping out. Methane is a greenhouse gas. If we add to the methane load in the atmosphere, we will warm the atmosphere. And what that particular accounting approach does is it makes that ambiguous and less clear. And institutionally is that what we actually see is the standard global warming potential approach is embedded in the Paris Agreement and in the Glasgow Agreement. And so countries can muck around with and pretend that they're actually doing stuff using other emission metrics, but the actual emission metric that matters in terms of the global atmosphere is the same as it has been.
Thank you.
I could ask a question about that as well, or but I won't. Oh, yeah, it's on. Yep.
Yep.
Hi, I could talk about that as well, but I'm not going to because it's quite a big issue. I'm interested in the very bland, non-emotional, or not non-emotional, but the excessive focus on human impacts to humans in terms of human health and all that sort of stuff. There doesn't seem to be anything in there that includes impacts on the occupiers of landscapes other than humans. For example, I'm from the Esperance region, and we had some severe heat waves several years ago, which killed large numbers of trees throughout the district. We had flocks of Carnaby's cockatoos, which are already endangered, dropping out of trees dead from the heat impacts. Yet the focus is constantly on how it's going to affect us as humans and not on how it's going to affect the other inhabitants of this planet at a local and regional, local level.
Yep. I'll just short circuit this. There's actually a huge amount in the IPCC Working Group 2 report on impacts of climate change on ecosystem and also on ecosystem-based adaptation responses, nature-based solutions, and to a much greater extent than any previous IPCC document. And so, for example, on that feasibility table, you actually can see ecosystems popping up in multiple places. So that sort of view of it's all about the humans and not about the natural system is simply not borne out by if you actually went and read the report.
Just a super quick one. Hi, I'm Sally. Thank you very much for a very sobering presentation. Thanks for a super
I just stand in front and speak into the mic.
And
yeah.
Yeah. And so
It's climate change.
Okay, is that better? What's the meaning of climate change? No. Thank you very much. Much appreciated. Very sobering presentation. I just had a quick question about if you could just give a little bit more context. You had as part of your graphs there, you had that the plant growth and crop growth is overall a negative impact over time. I do have, quite a few people say to me that, oh, there's more carbon in the atmosphere, therefore our plants are going to grow really well. Can you just comment on that, please?
Yeah, and so this goes back to work done well over 100 years ago, where if you add carbon dioxide to the atmosphere, plants become more water use efficient, more radiation use efficient, more nitrogen efficient. And that's well understood, and there's been a huge amount of work on that. It doesn't actually translate to the real world when we actually have actual climate changes. And so where your vapor pressure is going up, vapor pressure deficit is going up, where you're perhaps getting less rainfall or less seasonal rainfall and your soil moisture is going down. And so, yes, there is a benefit from having higher carbon dioxide, but the clear evidence is that it's not offsetting the negative impacts of higher temperatures and changes in rainfall. And that's very clearly identified in that global graph that I showed of how climate change is already impacting on agriculture. So if carbon dioxide was dominant there and it was actually benefiting agriculture more than climate change, we'd actually see blue colours on that map, but we weren't. And that's because the climate influence is much, much greater than the carbon dioxide influence.